Thanks, Mia, and the rest of the crew that made this happen, and thank you everybody else for coming out on Saturday to join us. Yeah, applaud yourself. All right. Yeah. Like Mia said, my name is Trey Riddle, and my company is Sunstrand. We're actually located in Kentucky, but I do have a little bit of a connection to New York, and I was very excited to hear that one of my alma maters will be participating in some hemp trials. I have a master's degree in mechanical engineering from Cornell, so I think I'll be reaching out to somebody over there soon. We do a lot of work in conjunction with universities. We take the research side of this very seriously. We work a lot with the University of Kentucky and others in the state of Kentucky, but we're also actively the only commercial processor of hemp fiber and hurd in the form of a decortication facility, which I'm going to tell you a little bit about, I guess. Yeah, all right. So I give a lot of technical presentations, so I might follow that a little bit, but I'll talk about our company background, and then I'm going to move into a little bit more educating, I think. A lot of this stuff most of you may already know, but I thought I'd cover some basics, talk about processing, and then a little bit about actual hemp fiber properties and applications as we try to raise awareness and really put a fine edge on where this industry can go and take it out of sort of ambiguity and into a very direct approach at targeting applications. Sunstrand is not a hemp company. We are a biomaterials company. We supply natural materials to a variety of technical and industrial applications. Our particular emphasis and market segments are plastics, polymer composites, and technical nonwovens. And you'll learn a little bit more about those as we go forward. Having said that, we are doing a variety of other things. We are in spinning trials for long staple spinning with our hemp fiber, as well as short staple spinning for blending with other fibers like cotton for textile applications. We do a lot of work on the hurd side. Besides plastics, which is our primary emphasis for the hurd, we're working right now with people and delivering horse bedding and kitty litter and some other applications. So what we do is we take raw agricultural feedstocks, and our emphasis is on bamboo, flax, kenaf, and hemp. We then process our products or manufacture our products, which take the form of fibers or particulates. Those then go into upstream manufacturing processes, of which there can be several before actually ending up at the end user. In general, we're fairly low in the totem pole. We're somewhat invisible in that respect. You might think of us as BASF makes chemicals, or Owens Corning's makes glass fiber, we make natural fiber for upstream manufacturing applications. It turns out that manufacturers really need alternatives to existing materials, the glass fiber, carbon fiber, plastics. What they're looking for are reductions in cost, reductions in weight, support for end of life like landfilling, compostability, or biodegradability is going to become a larger issue in the future. Additionally, just generically reducing environmental hazards. A lot of our work with composites has to do with glass fibers, and there are a lot of environmental hazards associated with fabricating with glass fibers. And then there are other technical issues like surface area per unit weight and volume, which I won't go into. Turns out that our materials like hemp offer a lot more than just those points. We also find that manufacturers and consumers believe them to be quite attractive, which is very exciting, and it takes a lot of emphasis in architectural applications for that, privacy dividers, lighting, things like that, but then also in textiles as well. We can meet a lot of the performance metrics, beyond the ones listed in the previous slide, things like stiffness and weight targets and strength targets. And lastly, there is an aspect of eco-friendly marketing that is attainable. Generally, that's a bit of an intangible value to people, but the idea that existing manufacturers today can bring on new product lines that they can then market to an eco-conscious customer base can allow them to increase revenue streams. I'll talk a little bit about our team. I think in some cases we may be a little bit different than a lot of people in the hemp industry. We're not farmers. We don't pretend to be farmers. We came out of the industries we serve. We came out of the plastics and composites and automotive markets. And that enables us to understand the specification of the materials, which is absolutely necessary for the penetration of them into the mainstream markets. Myself, I have a strong polymer composites background. Everybody on our team has a specialty, be it automotive or polymers or just generic engineering for our processes. Then we also have a large board of advisory members because we realize we don't know it all, and in all cases we try to reach out and talk to experts to help us along the way. Whoa. Oh, I guess those slides were timed. At any rate, we are an industrial supplier of raw materials. We are not an end-use manufacturer. We don't make the final goods. We sell stuff in bags and in compressed bales, big bags, this big bags. I did it again. What that means is, our whole goal and our impetus is to be a robust manufacturer, to have a solid understanding of the supply chain, to have redundancy in our supply chain, and to deliver repeatable, reliable products into the industry that meet our customer specifications. And the reality is, in order to do that, the materials that we bring in have to meet our specifications. And the work done at the farm level is absolutely critical. In effect, garbage in is garbage out. And so we work very closely with farmers, and we direct contract with farmers to grow our crops to our specifications. We work with the University of Kentucky to develop best growing practices so that we can ensure the farmers know how to do that, and they have the support not only of us and not only of the professors there, but then also the extension agents as well. We find that is extremely important, especially when it comes to hemp, which people haven't been growing for a long time in the United States. I'll talk a little bit about, we call it generically fiber processing, but the honest truth is that we're really herd processing. We're not really even a fiber company, we're a herd company. So the stalk of the hemp plant is made up of two major components: the outer sleeve, which is a bast fiber, and the inner woody core, which is called hurd or shive in some cases. Hemp is not unique in this aspect. It belongs to a family of bast fibers. They all vary in subtle degrees, but at the end of the day, they're made of these two main constituents, of which there is significantly more hurd than there is fiber in that stalk. And when you go through the process, you're essentially yielding both of those components. This is my challenge to you. Which one is hemp? Oh, I heard a couple of correct answers, the bottom left. That's right. The rest are not hemp, although they are extremely similar plants: canaf, jute, and flax. And I think it's important for people in the hemp industry to understand that while hemp has a lot of great qualities, it's not wholeheartedly unique. And it is, at least not in the sense of our industry in terms of the fibers and the herds. It is unique if you start talking about the flour and the oils and things like that. But from my company's perspective, hemp is one of many arrows in our quiver. And in order for hemp as a fiber to exist in the marketplace, it's going to have to compete with other materials as well. One of the things I run into a lot are discussions about novel decortication techniques. The reality is that the technology exists today to do decortication, and it has for thousands of years. It's only gotten better. Decortication is simply the act of separating the fiber and the hurd into their individual components. I like to group it into two camps. You've got artisan and you've got industrial. And so the bottom left picture is a hand brake that's been used forever to hand brake hemp and start the decortication process. There's several more steps that would follow after that. And the bottom right is one piece of a major industrial manufacturing line. The artisan side, there are smaller units, mechanized units as well, not just hand brakes, but there's smaller ones that you can shove materials into. Essentially, generically, in an artisan process, you're feeding your machine or your decorticator by hand. Lots of times they're doing what are called shocks, which is sort of the iconic teepee structures you see in the fields of old hemp pictures and whatnot as part of the retting process. There is even some people out there working on in-field decortication where it's like a tractor-mounted type of an application. But I'll lump that into artisan as well because fundamentally I don't see it as a major solution to service of major industrial applications of the crop. The other side of that is industrial. This is a type of process my company is engaged in presently, right now, today. We take bales, large 600 to 1,100 pound bales, directly from the farmers and put the bale in one end and get fiber and herd out on the other end. These are centralized models. These are large industrial scale facilities that are in a big building with big storage, big electricity demands that have to put out millions of pounds of material a year to be successful. Talk about something about the fiber's properties and then the potential of it in the industry. Okay, a few realities I guess I like to set straight. Hemp fiber is not the strongest natural fiber in the world. Fibers in general are highly variable and they have a spectrum of properties. Hemp fiber is a contender in some situations to have higher mechanical properties than others and not as high in many cases as other plants as well. Flax is generally seen as, in a lot of times, a superior technical fiber. It can have higher properties. Just so you know, there's caveats with all of these things. Hemp is not as strong as glass fiber. It's a fundamental engineering principle. It is not true. Hemp is not antimicrobial. Hemp fiber is not antimicrobial. Hemp fiber is not compatible with all major manufacturing processes. What hemp fiber is, it has a great strength to weight ratio, which makes it extremely attractive in many applications. By that I mean it has a low density. The fiber and the herd both have a very low density. Matter of fact, the density is less than carbon fiber and almost half that of glass fiber. It is, however, a very versatile natural fiber, which makes it extremely attractive and does bolster the business case significantly. Here's an example of natural fiber properties. I don't expect you to understand this graph. I'll tell you two important characteristics of it. One is the slope of the line, and one is how high the line ends as it goes up the graph. The steeper the slope, generally the stiffer the fiber and the better performing. The higher the point on the graph, the higher the strength of the fiber. You'll notice that hemp is not the strongest. It does not go all the way up to the top point, nor does it have the largest slope. But it does serve quite well as, it does have good properties and has many applications. This is data we generated. We generate this data all day, every day. We know a lot about fiber properties. There are an amazing amount of applications. I mean, it's virtually endless applications if you start thinking about plastics in general. We're focused primarily on plastics, polymer composites, and technical nonwovens, as I said. A nonwoven mat is there on the left. It's basically a felt. On the right is a thermal formed version of that went into a door panel. So that is a composite and it is a nonwoven mat where it's been blended with plastic fiber and became a rigid structure. Other nonwoven mats are used in things like filtration and even paper is considered a nonwoven. Significant amount of market segments and opportunities for hemp as a material to go into, everything from green plastics generically as a filler. Many of the plastics in your everyday life today can have hemp put in them in significant amounts, like 40%. We don't need to create new polymers. We can actually put hemp into existing polymers. That's very exciting. Today, technology, we do it all the time. Sports and recreation, always early adopters of new materials, great market segment. Building materials, very eco-friendly, LEED certification, great opportunities there. Automotive, lightweighting, absolutely critical, enormous opportunities there. And of course, consumer goods, as it resonates, I think, with all of you here, it does with many people. In terms of the market size, just to give you a sense from our perspective, the plastic supply market is about an $80 billion a year market. Our targets are primarily polymer composites and nonwovens, a $15 billion a year industry. Easily, there's a $200 million near-term addressable market for biomaterials, of which hemp is a piece of that puzzle, and arguably probably destined to be the larger piece of that puzzle, but yet still one piece. Whoa, that's fine. Where are we at today? This is an old picture. This is of our processing line. It's really actually just shortly after we got some equipment in the door, and you can see there's still a pallet. This picture is about 4 or 5 months old. Our processing line consists of 16 different pieces of equipment. It's not one magic piece of equipment. It is a bunch of pieces of equipment. Our plant can do 6 million pounds a year. It's about we designed it at 900 pound an hour capacity input. We've achieved as much as almost 1,100 pounds input capacity. That scale, our next level, our industrial scale, would be about 44 million pounds a year capacity. I believe that near-term addressable market can support over 12 of these plants, and we have market data to back that up as well. What does that mean? In purpose-grown fiber crops, that means about 60,000 plus acres of material for our market segments only, not the broader textile markets and generic plastic markets. So in summary, hemp is an extremely versatile plant. In that I mean fiber, grain, flowers, oils in that sense. It has good fiber, but there's lots of competition out there, and it has to compete to be successful in that perspective. There are a heck of a lot of potential market segments that it can play in. The technology exists today to make this happen. We do not have to create any new technology. We can do this right now. Well, barring some legislative actions. And it'll provide a support for a significant amount of farmland. And it may not necessarily be, in all cases, the small farmers, but it will bring a new industrial crop to the forefront that doesn't take away from edible crops, and it provides incrementally additional value in terms of contracts to those farmers. It's a very exciting opportunity. We're very excited to be a part of it. I encourage you to come visit us in Kentucky. Thank you.